So, as you set this up, you're going to want to typically try to get your sample to fill the screen as much as possible. Again, be careful not to run your sample into the X-ray tube. And then you can also recheck your sample to see how sort of centered it is, if you wanted to, by putting it on rotation and spinning it around, which you should do anyways, because you want to make sure that histogram is okay for the full 360 degrees of your sample. So, you know, you don't want a histogram if your sample is really thin in one direction and thick in the other, where your histogram either goes into over-intensity on in one position or completely disappears on the in another position. The other thing you're doing is you're looking to see if your sample is relatively centered. If it's not, or if it's way off, you can you might decide to take your sample back out and remount it, or try to figure out what needs to be done to improve it. In this case here, I'm not going to bother to do that. The system does have an ability to do some tracking, and so we'll use this as an example to show that. But nonetheless, it's still important to confirm that as you rotate your sample, that pieces of it don't fall outside the field of view. At least another useful thing to check is the target current for your given focal spot mode and voltage. Currently it's 50.4 microamps, and if I look at this chart, I can see that for a tube voltage of 80, which would be about here, on the largest focal spot mode, I should have about 50 microamps. And I do, I've got 50.4. So, in any event, this helps me understand that everything's running okay and that the system is probably reasonably well aligned. Since I am using the open tube, that's think of it sort of as a SEM system. It's got some ability to do alignment and so forth. And I'm not going to do the alignment, but if I wanted to do the beam alignment, I could click this button. I don't know if you can see it, but I could click this button right here, and the system would try to do a automatic beam alignment. At this point in time, I'm not going to bother to do the alignment because the target current is pretty much right where I expected, or even potentially a little bit better. So once you've kind of got your sample set up and and you're convinced you think you have the conditions you would like, you're going to end up doing a black calibration and a gain calibration. And you can do those manually, or you can do those automatically as part of the data collection process. The important thing to understand, black calibration is down here. Again, I'm not sure that you can see it, but if I was to click on black calibration, it's basically going to do a ghost. It's going to do a ghost removal. Basically, it's going to shut off the X-ray source, and it's going to wait for the ghost image to be removed. And essentially, after a certain amount of time, it will then try to ensure that all the pixels have an equal amount of blackness, so to speak. And then there's also a gain calibration. That's the button right beside it. When you do a gain calibration, the first thing you're going to do is you're going to remove your sample from the field of vision. The gain calibration is to ensure every pixel has an equal amount of whiteness or brightness. If you were to do black calibration, you just click on the black calibration button, and the system will switch off the X-rays. And wait for the ghost image to be removed. Okay, so for the black calibration, after the X-ray has been shut off for roughly 5 minutes or so to get rid of the ghost image, basically you just hit the black calibration button. It starts the black calibration. It only takes it, I don't know, maybe 30 seconds or so, and it'll be done. Okay, the black calibration is now finished. Okay, now we're going to do the gain calibration. To do the gain calibration, we're going to have to move the sample outside of the field of view. We could use that using the handheld controller that we used to position the sample originally, or we can use the software. If I use the software, I'm basically going to use this lower right-hand panel that has all the axes, and I can use whatever option I want to remove the sample from the field of view. Typically, you're either going to use vertical or horizontal. In my case, I'm going to click in the vertical box, and I'm not going to say go to 0. Right now it's at 146. If I say go to 0, that will literally move it from 146 to 0 millimeters. Instead, I'm going to click on the 0 button, which just gives it an artificial 0. Once I've done that, I'm going to type in -30. That's just a guess. Hit enter. My sample is now out of the field of view. And now I can go back to the gain calibration. And start it. So right now the system is doing the gain calibration. That takes, it doesn't take very long, a minute or two maybe. Okay, now the gain calibration has been done. At this point, I'm going to move my sample. I'm going to change it from -30 to 0, since I had set our artificial 0. And my sample will move right back up to where it was. The gain calibration has been done. One comment about the black and gain calibration is you do not necessarily have to do them at this point or do them manually. There are options where you can select some little toggle switches right before you start collecting your tomography data, and the system will go through the process for you. But it's important that you see at least once how to do it manually. And I think you will often find yourself using this, like if you're concerned that you expose your detector to large over-intensity or something like that, then you're probably going to want to go back through and do things like check your black and gain calibration. Okay, now that we've done black and gain calibration, we're going over to the tomography screen and the section panel on the right-hand side of the monitor. We're going to click on the project directory. We're going to drive to CT data, find the group, and folder that we want to put the data in. So I've done this, I've hit select. This folder now shows up in the project directory. I can put some sort of image prefix name in here. Basically the system is going to update all your images by 1, so most people probably start with either 0 or 1, and then every image of the multiple images you take will increase from there. I can come down here to type. I have 3 choices: tomography, which is conventional tomography, where it's just going to rotate my sample 360 degrees or whatever I tell it to. And you know, because the sample isn't going to move up or down, it's just going to rotate. I can use helicoil, which is, think of it as screwing something in, right? It's got a helicoil sort of motion. So you could basically start at one end of your sample, like if you had a long skinny sample, and then your sample would slowly twist up as you were collecting the data. Or you can do stacked. So stacked would be, instead of doing a helicoil, you could actually stack images on top of one another. So if you had, again, something tall and thin, you couldn't fit it in the full field of view, you could do a stack of 2 or 3. You cannot do arrays. I think that's just a little too complex for the software. Okay, so we're going to select tomography. And then we're going to go to down here for options. We can do, there's several options. There's actually notes. Typically, most people probably do continuous and reference images. Although for this demo, I could get away with just doing continuous, because it's not going to take very long. But nonetheless, I'll do the reference images. The reference images are very important, especially if you've done a long run. If anything has changed, those reference images are images that are collected at the end of the tomography, so that you have comparison images, say every 10 degrees or so, that you can compare to your original data set. And you can use that to make sure the images are aligned and so forth when you do your reconstruction. So they are important, even though they're really not needed for a demo. I'm going to do them anyways. In most cases, you will do them. If you pick some of these other options like 6 passes, I mean, literally 6 passes means you're going to rotate your sample 360 degrees 6 times. Likewise, there's an option for 4 pass and so on. So I've picked continuous and reference samples, and then I can set the images per turn, or if I want, I can select auto. If I select auto, it puts in how many images per turn it thinks I should have in this particular. So after you've set up your project directory, you know, decided your type of tomography and what options you were going to use,